and welcome to another session of Team Canada's Tech Thursdays. My name is Wael Al-Nuwaisri. I am a sales engineer with Watchguard Canada, and today's topic is going to be the Wi-Fi must-know fundamentals, which is a very important session that's going to lay out the basics of Wi-Fi. So let's take a look at the agenda here. First thing that we're going to be talking about is the Wi-Fi terminology, which is, I know that it's a topic that it is not very interesting for a lot of people, but it is a very important one so that we can set the language that we're going to speak with the client whenever that we are reading an RFP or whenever that we are talking with our sales reps. The second topic that we're going to cover is the importance of planning, especially when it comes to the Wi-Fi and how that's going to affect our design. And definitely we're going to touch here on the Watchguard design service that it's available for you as a partner. We're also going to talk about the coverage, capacity, density, the definition of these terms and how they affect the process of the design, planning, implementation of our Wi-Fi, and definitely in relation to the WatchGuard access point models that is available for us. We're also going to cover the spectrum of availability and the management and why we should design with specific points in mind. And at the end, we're going to have a couple of minutes for taking question and answer related to today's session. Great, let's get started then. And we're going to start here with the Wi-Fi terminology. And the first thing when it comes to the Wi-Fi is the wireless bands, when everyone knows that we have 2.4 and 5 gigahertz. So let's start here with the definition. When we are talking about a wireless band, a band is a section of the radio frequency spectrum that is dedicated to a specific purpose. And for this example, we are talking about 2.4 gigahertz and 5 gigahertz band that is used in the wireless communication. When we are talking about 2.4 gigahertz, so this frequency band is also shared with other devices like microwave, wireless monitoring system, Bluetooth, mobile devices. And I wanted to point this out so that you will understand that whenever that you are designing your Wi-Fi, that this is specific band, it's also shared or affected with the interference from other devices. Also, when we talk about 5 gigahertz, this frequency also shared by radar and other location system, and we're gonna talk in details later on when it comes to these points. Now, the range of frequencies within a channel is called a channel width. And this is the term that is important for us. And I will show you later why it's important. But for example, if we're talking about the 2.4 gigahertz band, it's going to have approximately a 22 megahertz of frequencies when it comes to the channel width. The frequency range of the channel overlaps with adjacent channels and can create the interference with other devices. So this is why the channel width is important, especially when we're going to be talking later on with concern about the 5 gigahertz channel. Now, let's take a look at the 2.4 gigahertz band here. As you can see, we have multiple channels that's available, but the most important one that you need to remember is channel 1, 6, and 11. Why they're important? Because these that are the non-overlapping channels that we have. So they are important for our design. Now, so what's the good about the 2.4 gigahertz? First of all, that it's much better range. It has much better range than the 5 gigahertz wireless network. And also the waves can better penetrate the solid obstructions. So when we're talking about floors, walls compared to 5 gigahertz. So when it comes to the coverage, when it comes to the penetration through the wall, we definitely have to plan for the 2.4 gigahertz. But what's the bad? The first point here, when we talk about 2.4 gigahertz, it's very congested because there are many devices. It's been there before the usage of 5 gigahertz, and there's a lot of devices using this band, and there's a lot of interference, which is going to affect the performance for sure. The other thing is that it has fewer non-overlapping channel compared to the 5 gigahertz because it's only 1, 6, and 11. And especially if we're talking about a building that has multiple floors and you have neighbors, around you, and also in the upper floor and the lower floor, you will see that only 1, 6, and 11 is being used, and definitely they will interfere with each other. Now, when we talk about the 5 gigahertz band, and for this specific diagram, we are talking about the 5 gigahertz spectrum in the United States for this diagram. And we are talking about 20 megahertz spatial or separated. They are separated in 20 megahertz for the unlicensed national information infrastructure, which is, we could call it here, as you can see, we have Uni 1, Uni 2A, 2C, and Uni 3. And according to what we have, and the first thing that we're gonna notice in here, especially if we're talking about the 20 megahertz width that that's available, we will have much more non-overlapping channels that we can use for the 5 gigahertz, which is definitely is going to help us with less interference, and also it is less congested, and it's going to give us better performance. Using this 20 megahertz, there are 24 non-overlapping channels that's available, and this actually depending on the country. We're going to talk about Canada later on in this session. Now, 20 megahertz, 40 megahertz, or 80 megahertz when it comes to the width of the band. What's the difference? Now, according to the 802.11n standards, there was an introduction to something called channel bonding, right? Where we can take multiple channels, bond them together so that we can offer more throughput using this channel bonding. So when we talk about the 802.11ac, also that it's extended it to allow for 80 megahertz and also 160 megahertz channel. Now, bonding definitely is going to increase the throughput, which can improve the performance. While this 40 megahertz have the higher throughput than the 20 megahertz, also it's going to reduce the number of non-overlapping channels, which is going to increase the probability of the interference. So in addition, not all Wi-Fi client devices support the channels other than 20 megahertz. So compatibility also can be a concern. Always, we're going to have some positives and we're going to have some negatives, and we have to balance it in a way that it suits the requirements in that specific scenario. Now, what's good about 5 gigahertz? Definitely it's faster, right? It offers faster uploads and downloads than the 2.4 gigahertz. Also, it benefits from more non-overlapping channels and less interference, which can boost the performance. What's bad about the 5 gigahertz? It is not as good at going through the walls like the 2.4 gigahertz. 5 gigahertz has lower coverage range, and also some legacy clients devices only support 2.4 gigahertz. So all of that have to be taken into account whenever that it comes to the design. The next topic that we have here when it comes to the terminology that we need to understand is related to the wireless antennas. And as we know, when it comes to the antennas, we have the one that it is external, we have the internal or built in into the device itself. Now, when it comes to the shape or the transmission of the power, we have the directional antenna and omnidirectional. So what's the difference between them? The omnidirectional antenna can transmit and receive within 360 degrees. Definitely, it's not exactly 360 degrees. When you take a look at it, maybe it's going to be 270, 300, depending on the chart that it is available for us. But most Wi-Fi access points and clients use these omnidirectional antennas to support connection from any direction and provide the widest signal coverage. Now, with the directional antennas, it's going to direct the signal in the direction where the antennas points. So, for example, if I have a specific structure or a specific building, like for storage, and we need through the corridors to have more power to cover only the corridors, then we're going to use something like this directional antenna. One of the other important terms is the beamforming, which is technology that is going to enable the wireless devices with the omnidirectional antennas to detect the location of other wireless devices, and it's going to direct a stronger signal in the direction of that device. This beamforming it provides a stronger and faster Wi-Fi signal, and it's fully supported with 802.11 AC access points and the clients. Another important term here, you can come across it in different data sheet or sometimes in RFPs, is MIMO. So what is MIMO, right? It is multiple input, multiple output that is going to support multiple spatial streams. So for example, a 4-antenna device with MIMO technology is commonly called 2x2. So you have here 4 antennas, but it is, when it comes to the sheet, they tell it is 2x2 MIMO because it has 2 transmitting antennas and 2 receiving antennas. Similarly, if we're going to talk about a 3x3, right? So here we are talking about 6 antennas, and we, depending also, we have 4x4 and so on. And another important thing to mention in here that you will see wave 1 and wave 2 access points. So what's the difference? And here we take an example, we have AP420 that it is 4x4, right? If we are talking about wave 1, which is, as you can see, it is not multi-user, it's a single user MIMO. Now, all streams supported by the client, they're going to be in use. So depending on the spatial streams that it is supported by the end user device, is going to affect definitely the performance. But in this scenario, it's at any time, this specific access point is communicating only with one at a time, right? Other clients have to wait for their turn. With wave 2, we're going to have M, not S. So it's multi-users MIMO. And the 4 streams are going to be working at the same time to serve multiple clients as needed. All right, some terms that you're going to come across when it comes to, again, the requirements, or whenever that you are filling the survey that we're going to take a look at later. First thing is the signal strength. It's the wireless signal power level received by a wireless client measured in dBm, right? The value is usually 0. The stronger, if it's closer to the 0, it's going to be a stronger signal. So for example, if I say negative 45 dBm, it's going to be better strength than negative 65 dBm. It's something that to keep in mind whenever that we are talking about the signal strength. The noise level, so this is the other hand, right? This is the noise level, the interference that's going to happen in here. So indicates the amount of the background noise in the environment. So the closer the value to 0, the greater the noise value, or the noise level that we have. The negative values indicates less background noise. So for example, if I say negative 96 dBm is a lower noise level than negative 20 dBm. We also have another term, which is the SNR, right? Which is signal to noise ratio. And we talk about the strength, we talk about the noise. So, okay, what's going to happen? We put the two together. So it's the power difference between the signal strength and the noise level. The lower value than positive 25 dBm results in a poor performance and speeds. So for example, if you have a negative 41 dBm signal strength, and a negative 50 dBm noise level, then definitely you're going to have an issue here, because the result is going to be a poor signal to noise ratio of +9. RSSI, it's another strength of the signal measurement. So this is a received signal strength indication, or how strong the signal is received by the antenna of the wireless devices. Radio. As we know, all Wi-Fi and Bluetooth devices contain a radio transmitter and a receiver connected to internal, external antennas, which is we talked about that in previous slide. A device that can transmit on multiple frequency bands usually has one radio for each frequency band, right? So we have two radios, which is 2.45 gigahertz, and each one of them have a sender and receiver when it comes to the different spatial streams. Now, the standards, it's sometimes difficult to remember all of them or memorize, each one of them. Some of them have been around for a long time, but 802.11, that's where we start. And we're going to have the band, which is 2.4 gigahertz, and the maximum data rate of 1 to 2 megabit per second. Channel width is 20 megahertz. And we're going to go to A, B, G, and N, all of the current access points. They support all of that, and the AC, which is the AC, it's making use of the 5 gigahertz, and we talked about the wave 1 and wave 2 with single user MIMO and multi-user MIMO, and as you can see here, always the channel width that it's accompanying these specific standards. So if we, for example, we take wave 2 here, which is in theory, we say it's 1.7 gigabit per second, right? This is going to be much lower, and we're going to find out why it is much lower because of different factors that we have in our environment. We also have other standards, which is for the IEEE 802.11, the amendments to the main standard, right? So, for example, if we're talking about I, then it's related to WPA2, which is related to the security. We have for quality of service, hotspot. Some of the important ones, which is we have here. It's related to the KRV, so it's also related, for example, when you're talking about R, it's related to the fast, secure roaming that's going to happen, and also later on I will show you where this specific configuration can be done. But I just wanted to point here that sometimes the usage of these amendments or enhancements, it doesn't work for all the devices. So for example, if you're using 802.11r, which is supposed to be enhancing the roaming and the handing over from one access point to another, we have issues sometimes that happens with iPhone, for example. Great, so that was the terminology. So now we are speaking the same language when it comes to the Wi-Fi basics, right? Now the importance of planning, why design and planning is vital to Wi-Fi. It is not, definitely Wi-Fi is very crucial when we talk about planning, right? So when we are deploying the wireless LAN, design and laying down all the requirements, we need to have the definitions, the design, the installation, testing, and operational support, laid out for us during the process. And we do this so that we're gonna avoid the inconsistent delivery of the service and the unhappy users, and definitely we don't want to lose the clients that we have. So the first thing we're going to talk about here when it comes to the planning is to evaluate the requirement, right? Sometimes these requirements is just by email from the end user or from the organization. Sometimes it can be an RFP, but we need to make sure that we need to consider. Sometimes they hire you as an expert to come and design their Wi-Fi. So the first thing we're going to think about is what wireless modes must user access point support when it comes to different type of standards like ABG, N, AC, Wave 1, Wave 2, and so on. What SSIDs and networks that they want to create. So they will tell you, okay, we need one for the IT, we need one for the staff, we need one for the guests, well, maybe for the guests Wi-Fi access. We don't want them to access anything internally. We just want them to access directly to the internet and so on. Also, where is the best physical location for each access point? So this is depending on the physical size of the environment, where the wireless users is going to be concentrated, the type of the physical location itself. Definitely when we're talking about an office, it's going to be different from a school, different from a church, and so on. Do we need more than one AP to cover multiple areas with the high density? All right, so usually when we are doing our design and planning, the first thing to come to mind is the coverage, right? So the coverage planning, that we have enough Wi-Fi coverage for our environment. So we need to think first about the optimal frequency users and also the access point locations. Sometimes we are replacing other access points, so we can take that into considerations. Sometimes we have a new project, so we need to know the layout, the dimensions, the optimal frequency is going to be used. So we are talking about the different type of devices and if they are supporting 2.4 only, or they can support 2.4 and 5 gigahertz. The determination of the transmission power levels when it comes to the access point. So is it says to be within 17 dBm, 20, depending on the environment that we have, number of access points. So what I'm talking about in here, if the power is not optimized for the radio frequency signal, you're going to have bleeds. So we talked about the channel 1, 6, and 11, which is non-overlapping. But if there's each one of these channel is screaming with power, then we're going to have a bleed between these different channels, and it causes the interference. So sometimes we need to optimize it in a way that that is going to improve the application performance. Definitely prevention of channel interference when we talk about the coverage planning. The examination of floor plans, physical abstraction, and building materials is very important. And this is one of the things that's essential. You have to have somehow this information that is related to the layout, the dimensions, the building materials, that it's going to help you a lot, including whenever that is coming to the predictive survey, which we're going to talk about in a minute. The other type of design that we are talking about is the capacity planning. So we have coverage and we have capacity. Definitely we need to think about both of them, but when you talk about capacity planning, we are talking about the optimal number of clients per access point radio, including so the idle and the active clients. You must factor in also the slow periods and the worst case users scenario. So again, when we are talking about some places, sometimes we have events. So when we have a spike, we have to take that into consideration as well. The airtime demand and minimum data rates for different types of application traffic. So definitely, if I have an environment that all the time that they're streaming high definition video through the Wi-Fi, the airtime demand is going to be higher, throughput that's requirement is going to be higher. The bandwidth throughput per application connection. Also, we're going to determine the aggregate bandwidth required in a wireless network coverage. The consideration of growth. Sometimes, a lot of people miss this point of saying, for now we have 30 users. Yeah, but 30 users, they're gonna grow over time for the next 3 to 5 years by how many percent? 10, 15. They're gonna double. What about the devices? Currently, they're using 2 devices. Maybe later on, each user gonna have multiple devices. Some other points to consider whenever that it comes to the planning, and a lot of people forget about this one, and they will tell me, "Oh, this is a Wi-Fi session. Why are you talking about wired network?" Because it's going to be your bottleneck. Whenever that it's if you don't take that into consideration. So one of the things is related to the AP power requirement. So depending on the access point, does it require PoE or PoE plus? Do you need a new switch that to support that? Are you gonna buy the PoE injector and so on? Also, the type of switches that we have, the speed of these switches, the uplink speed, the internet speed, because sometimes you forget that, okay, even if you did the best design when it comes to the Wi-Fi and you have best coverage and the throughput that you really wanted, but at the end you have only 1 gig coming to your access point, and you have only like 200 meg going to the internet. So the overall speed for a specific user, even if it's only 1 user going to the internet, it is now definitely going to exceed the internet speed that is available for you. Great. It's very important to have wireless site survey. You need to complete a site survey to analyze the physical environment and existing wireless signals. Right. This, it depends on the type of project. Sometimes you need to do it from the beginning. Sometimes you need to do a predictive survey first, and then you go do the wireless site survey. But there is a lot of utilities that it's available in the market that you can utilize to do the site survey and generate your heat maps as needed. Some tips when it comes to the wireless site surveys. First of all, measure before the deployment as part of your planning. So you're going to measure the wireless signal strength and interference before the deployment of the access point. Then, after the deployment of the access point, you're going to go and check again. Make sure that you deliver what you promised. Make another heat map to see if the current placement provides the best signal strength and best coverage depending on the scenario that you have. Check also for wireless channel congestion and make sure that the distance between the devices do not degrade the signal to a level that they're gonna call you the next day and tell you that didn't work for them. Other considerations here when we are talking about the site survey, and especially when we're talking about the capacity planning, you must consider the client types and quantities, the currently in use or anticipated in growth, right? So this is what we're talking about. You also have to plan for the future. The type of application currently used, and if there is anything new that is going to come into the environment, if they're using something when it comes to the streaming or a specific application that require higher throughput. Design for the capacity in mind, high quality floor maps that is going to help you in the process. Be very precise when it comes to the dimension. And some people sometimes they tell you, okay, I have a school, it is 400 by 200, and that's it. They don't tell you what's the height of the ceiling. They don't tell you how many classes that it's in there. So the more information that you have, definitely you can go and get it yourself when you do the site survey. Consider the RF leaks between floors. This is something else sometimes people they forget about, depending on the type of the ceiling and depending on the strength of the signal that is going to be used. Most of the time they just talk about, okay, how that's going to affect the access point in the same floor, but they don't think about the other floors as well. Now, how can we help as WatchGuard? We have one of the services that's available for you as a partner for free that definitely is going to help you to get an idea of what you need when it comes to the number of access points. So we have these team that is WatchGuard experts in Wi-Fi design. They're going to help you whenever that you fill the Wi-Fi requirements questionnaire, which is going to show you later on where to find it and how to fill it. You send it to our team, and usually between 3 to 4 days, they will get back to you with the predictive survey report, which has the heat maps, and it has the recommendation when it comes to the model number of access points that you should plan for. Okay, now when we talk about coverage, density, and capacity, right? Definitely we understand the words, but how they are related to Wi-Fi. And if you notice that there are some of these terms that I go over, more than once, so that you will understand it and you will use it depending on the environment and the scenario. Now, density is related to how many. Capacity is how much throughput or bandwidth that it's required. Coverage, simply the area and the zone or multiple zones that we want to cover. And as we know that sometimes you plan for a specific area that it has 10 users, 15 users, but let's say that in a specific period of time this number is going to be more. So as density and the user is going to increase, definitely the performance is going to be worse. And keep in mind there is a lot of factors that is going to affect the airtime demand and the performance. So the channel width, the spatial streams that is available for the end user devices, the signal quality, the protocol version, the frequency bands that's available, the application throughput that's required. All of these gonna affect the performance. So just to help you and give you an idea, to guide you, right? And here, this specific session is not a comprehensive reference for everything in Wi-Fi. It's just to highlight some of the information that's going to be useful for you whenever that you design. So the first thing is the requirement analysis when it comes to the clients. A lot of time when we think about Wi-Fi, we think about the access point, and we regard the devices that the end user is going to use. Is it a laptop? Is it a phone? Is it a legacy iPhone, and so on? So the type of the client devices and where they are located in the network is something that you have to take into account. So if I give you an example in here, and when we talk about the spatial streams, right? So if I say that a specific access point is capable of 3x3 and it is multi-user MIMO, great, all of that is nice, and the end user is not far from that access point, and we size it perfectly that it is not going to be overloaded. All of that taken into account, but let's take a look at the end use device. This is the receiver, right? And they have to match or match the specifics of the communication with the access point. So as an example in here, if you see, this is a chart of the maximum data rates depending on the device. And here, these are just examples. So the first one here, we're talking about Galaxy Tab Pro or Galaxy S4, right? These specific devices, they are only capable of one spatial stream. They cannot, even if your access point is 3x3 and it is multi-user MIMO and using 11AC, And at 80 megahertz, still can only understand one spatial stream. And that will achieve 433 megabit per second. Now, compared to the MacBook Pro, which is actually can facilitate 3 spatial streams, I can have almost 3 times the speed that I get with the Galaxy Tab Pro, which is it's going to be 1.3 gigabit per second, right? Again, this is theoretical maximum data rates, and it's going to be affected by other factors as we go. Now, when it comes to the capacity planning, you need to calculate how many concurrent connections you can support for each access point on both 2.4 and 5 gigahertz. You're going to take the average number of active and idle clients. Also, a client can be connected, but only send or receive minimal traffic, which is using half uplinks. Also, a client can use maximum resources, right? So if we have a video and it's streaming, or there's a file that's being downloaded, so it's using more resources for that specific period of time. Great. Other information here as a reference, right? When it comes to the applications, okay, we know the clients and we need to know about the applications that using and how much the average bit rate approximately that is going to be used for each of these applications. So let's take a couple of examples here. So if we are talking about video conferencing, which is very popular nowadays, right? So if we're talking about standard definition, it's going to be 1 to 2 megabit per second. But if we're talking about high definition, it can be 2, 3, sometimes goes to 5 megabit per second, depending on the standard that you're using. If we are talking about video streaming with high definition, 720 pixels, then 3 to 5. If we are talking about 4K, then we need 25 megabit per second for that specific application per user, right? Now, taking a look at the maximum clients for the APs that's provided by WatchGuard. Some of them here, they're legacy, so they are there for your reference, but we're going to take a couple of examples of the newer ones. So the entry level here, the AP125, which is dual radio, right? So it's 2.45 gigahertz, and we have the support for 802.11ac. It is a Wave 2. All of them now, they are Wave 2 access points. And it's 2x2. It's used for indoor. You can see the recommended use, which is for low density areas. And these are the throughput in a testing environment that's available for 5 gigahertz and 2.4 gigahertz. Now, these numbers is related to the maximum associated clients, right? If you notice that all of them is 254 except the 420, which is 510, it means that it can monitor all of these or register all of these maximum associated clients. But this is the number that we need to look at, the recommended concurrent active clients. And again, it's recommended, right? Depending on the environment, that number could be less, and depending on the application and so on. So if we talk about 125 here, that the recommended concurrent active clients is going to be 50, the rest of them is 75, and for AP420, which is for higher density areas, it's going to be around 150 concurrent clients. All right, and in this chart, I just wanted to point out, even if you sell firewalls, you know that when it comes to the advertised speeds and throughputs, there is a specific testing environment that it's used to achieve these numbers. Whenever that you are changing the environment, you're going to iMix, you have the overhead, the packet structure, all of that's going to affect things. So when it comes to the Wi-Fi, and this is just for your information, this is the advertised speed for 2.45 gigahertz. This is the maximum. It's going to go through all of these, right? So the first thing is the Wi-Fi device, the end user device and the access point. Can they support 2 by 2, 3 by 3, and so on? The radio interference. Are we using 5 gigahertz, 2.4? Is it high density environment or not? The number of streams between the client and the access point. Is it 2 streams? Definitely it's going to be slower than 3, 3 is slower than 4, and so on. Channel bonding that we talked about earlier, right? Are we using 40 megahertz, 20 megahertz, or 80 megahertz? Are we capable of having 80 megahertz in that environment? Now, this throughput is the maximum theoretical throughput in a clean environment and closed distance, right? Other things that's going to affect the speed. Half-duplex nature of the Wi-Fi communication with the end users, the Wi-Fi overhead, the contention that we have, the distance that is going to vary, the interference, legacy devices that doesn't follow the higher standards, the TCP acknowledgement retransmission, all of that, it can actually bring the throughput down to less than 1 megabit per second for each user. It's not always going to be like that, but it's things that's taken into consideration when it comes to the design. All right, now the following topic, which is going to be the last topic for this session, is related to the spectrum availability and management. We already talked about 2.45 gigahertz. Now, when it comes to the design, how we should think. Now, always plan for 5 gigahertz in mind, right? Even when it comes to the projective survey, and I'll show you a sample of it, we always plan for the 5 gigahertz because as you remember, that 5 gigahertz is going to have lower coverage by the disparate performance because it has much more non-overlapping, right? So definitely if I have coverage for 5 gigahertz, definitely I will have a for 2.4 gigahertz as well. So some of the things to take into account and that is resolved by the 5 gigahertz is the first thing here is the code channel, right? The code channel interference. So every client and access point on the same channel competes for the time to talk. So if it's this specific access point here and it is using 2.4 gigahertz and it's using channel 1 and everyone is competing in there. So this is one of the things that if you use 5 gigahertz that you can actually resolve that issue. Adjacent channel. So even if we're using channel 1, 6, and 11, we have sometimes a neighbor that will decide to say, oh, I'm not using these non-overlapping, I'm using 4, I'm using 5, all right? And how that's going to affect the performance that we have. So every client and access point on overlapping channels, they're going to talk over each other in that specific domain. The other thing is the non-Wi-Fi devices, like microwave, cameras, cordless phone, or sometimes specifically this one when it comes to microwaves, when it comes to lunchtime, right? And you see that the microwave is going to affect the 2.4. You use 5 gigahertz, you don't have this issue because these devices do not operate in the 5 gigahertz spectrum. Right, let's take a closer look here. And earlier, we talked about this diagram, the one that's used for the states. This is specifically used for the channel that is used or not used or not operationally permitted in Canada. Okay, so as you can see that we have the 20 megahertz channels that is available, the usage, so from 36 to 48, these are used indoor, 149 to 165, it's used indoor or outdoor. I have no problem with this, but there's one important thing that you need to be aware of, something called DFS, which is dynamic frequency selection. It's a mechanism that allows a wireless LAN to coexist with the radar system, because we said 5 gigahertz, we have an overlap with the radar. So as you can see, some of these channels actually we cannot use. It's used by Canadian weather radar, right? Some others, they are there, but we have to use the DFS so to increase the number of non-overlapping depending on the environment. So if we have DFS on, it automatically selects the frequency that does not interfere with the radar system, right? So when it comes to DFS channels, historically, we're talking about the past. It had some issue, this specific feature, right? Because of the concerns about the lack of client support and the network instability caused by the radar event detection, and it wasn't smooth. But, however, many networks today, they rely on this specific feature, and for most deployments, you don't have an issue with it. You turn it on, and it's going to increase the non-overlapping, which is going to increase the throughput and better performance for you, right? So we recommend that you use the DFS channel feature. If they are available for both 5 gigahertz and 2.4 gigahertz to have better performance. Now, here is a table that's showing how many non-overlapping channels using DFS and without DFS, right? So if the channel width is 20 megahertz, without DFS, we have only 9. With DFS, we have up to 25. If we go to 160 or 80 plus 80 megahertz, we have only 1 without DFS. With DFS, we have 3. Now, when it comes to the channel width selection, right? How we can do that? So wider channel, such as the 80 and 160, definitely is going to provide you with greater bandwidth and data rates compared to the 20 and 40. But also means fewer channels are available, and that is going to increase the possibility of the co-channel interference, especially in dense environment. So for example, if we have 160 megahertz, only 2 channels are going to be available for you. But if we're talking about 40 megahertz, for example, we're going to have 12 non-overlapping channels. If DFS channels are going to be available, DFS, it's going to be turned on. And 20 megahertz, no issues. We have many channels and combination that is going to be available for you. Now, the channel width selection, it's going to depend on some factors. These factors including the case requirement, the spectrum availability in that specific area or country, the RF environment, and the budget for the number of the APs required. So in general, here are some of the recommendations that we can give you. If you have high density and non-DFS deployment, then use the 20 or 40 megahertz channel. If you have low density and DFS channels are available, then you can use 40 megahertz channels. For well-designed deployment with DFS channels available, you can use 80 megahertz channel. All right, so we reached the end of this session, and here's the summary. First of all, design wireless network for the coverage with focus on capacity, right? All the time it's coverage comes to mind, but it's okay. Let's go with capacity. We have 5 gigahertz, and we have to focus on that when it comes to the plan. Now, the use case. Each environment, and sometimes even the same client will have different environments. You have to take that into account. So the number of devices, the type of the devices, the applications that's going to be used, the usage patterns, and a specific given area. Use most demanding application per use case to do your planning. If it is not available, then plan for an average of 5 megabit per second per user. Select the correct APs for the use case. So we showed you earlier that we have AP 125, we have the external, internal ones, we have the high density, depending on what you need. Design for 5 gigahertz capacity and then utilize both 2.4 and 5 gigahertz. The wireless network should be designed for average -62, -65 dBm or greater throughput at the entire deployment. And the last thing here is to use predictive planning tools to estimate the number of access points required, so to get or to meet the throughput requirements. Great, so what's next now? I'm going to show you a couple of things. The first one is the predictive planning tool, how to get access to it, how to fill it, and the information that's required from you. The example of the report, once that you submit the survey information, and also we're going to take a look at the dashboard and discover to show you where are the configuration for some of the specific factors that we talked about. All right, so let's take a look here where we can find the questionnaire for the Wi-Fi. Once that you logged into your partner portal, WatchGuard partner portal, you can go under Products, Selling Secure Wi-Fi, and in there you will see that there is a link for Wi-Fi requirements questionnaire. This is one of the places that you can click on this. It will take you to a form that you can fill online that's going to be sent to our wireless LAN team. Also, if you click here under Wi-Fi design services, it will do the same thing. That is going to open that link for you. So let's take a look at what are the questions that they're going to ask you. So the first thing it's going to ask you here is the project name. So let's say this is for a motel. You can put the company name that it is you as a partner or the client themselves. You can put the project description in here, like if it is new construction, what's the purpose of it. So let's say this is a 2-floor motel in Halifax. Then the next thing it's going to ask you is about the facilities, right? Is it an office, a retail, an education? So here we're going to choose hospitality. You can put the information about the site location as well. Is this is going to be inside and outside coverage or only inside? The dimensions. So in here, this is very important. You can get the dimension for the overall layout, but also you can include that information in the layout that you're going to upload by the end of this questionnaire. So let's say here we're going to change this to meter, and we say that the length of this is going to be 300 meters, and when it comes to the width is going to be 50 meters. And the next information required is about the interior wall material. And this information is important because it's going to affect how the signal is going to travel through your environment. The next thing is that we have the interior door material. Is it a hollow one, a solid core, a steel? The ceiling construction, is it plaster? Is it a drop ceiling? Then we have the ceiling height. Let's assume this one is going to be 5 meters for now. The interior and the exterior construction is both of them. They are important. So we're going to talk about, say that it's metal. The next information, if there's anything missing, it's going to take you back to it. So for example, the site location here, I forgot to say that it's in Halifax. The next information is the users and apps, and it's telling you that we are focusing here on 5 gigahertz, WPA2, and we can put more information about what are they using for the end users. For example, I'll say these are Dell laptops, HP, iPhone, and so on. Total number of Wi-Fi user expected, let's say is 200, but each one of them have, more than one device. So let's say we have 300 in total. Wi-Fi intrusion, so we have the option to say yes or no. The traffic type requirements, so let's say that we're going to be using all HD video, large transfers, We're going to be using web, email, and if there's any other type of requirements for the throughput. So let's say this is 5 meg that is going to be used. Continue here to the next thing that is related to the management. So is total Wi-Fi, secure Wi-Fi. This is the one that I want to use for this environment. How do you plan for the power? So I already have my own PoE plus switches. We are using here conduits for our network cables. And you can say here what's the capacity for the bandwidth capacity for the AP to the edge switch. So let's say that it is 100 meg, and this one it's going to be 1 gig to the core. And then the mounting, we're going to be using flat surface mount kit, and we're going to click next. And the last thing is to submit, and this is where you can upload your layout. If it's more than 10 meg, then you can actually contact the wireless LAN team at watchguard.com so that they will tell you how you can upload these information. Right, and then we're gonna click submit. So once that I submitted that, how it's gonna look like when it comes to the report. So this is how the report look like. Once that you receive it, you're gonna have the information about that motel, and then it's gonna take you here to the project description, how many floors, total number of users, and the facility layout that you uploaded to our questionnaire. And then you have the heat map by location for the ground and first floor, and it will show you for 2.4 gigahertz that you have the coverage, where the suggested AP location should be, and the same thing for the 5 gigahertz. So that since definitely 5 gigahertz have full coverage, definitely we have 2.4 that it's gonna cover the area for sure. And then you're gonna have the bill of material for the ground and the first floor. So we have here a 4325 and 31225W. And if there's any need for external antennas, in this scenario we don't. And you can see also we have the part numbers there for the surface mount kit that is required for these APs. Okay, the last thing that I wanted to show you is related, where can I find some of this information related to the configuration when it comes to the 802.11 configuration. So you are gonna go here under WatchGuard account, you're gonna go under Manage Wi-Fi Cloud, and in there you can go to Discover, and I'll show you exactly where this configuration is gonna reside. So I'm gonna go under Configure, and I'm gonna pick a specific location that belongs to me here. And under the SSID, some of the configuration that can be done is related to the RF optimization. So if I go to that and click on it, this is where you can see the 802.11K, which is related to the neighbor list, and also V. So this is where you can actually turn it on and off as needed. Another place that you can go to, it's related to the radio settings in here. So you can go to 2.4 gigahertz or 5 gigahertz, and you'll see that we have the channel selection. You can see the protocol that's being used, the channel width. Also, when it comes to the transmission power. So the minimum and the maximum that is auto, that is going to actually set it depending on the coverage that you have and how many access points that you have. And other configuration that's related to smart steering, smart client load balancing that we didn't talk about today, but maybe we can cover in another session. Okay, so that was all for this session. I hope that it was a useful session about the fundamentals of Wi-Fi. Please visit this link, or you can use the QR code to share your feedback with us. Thank you so much.